Good morning friends, myself AKSHATA SHELKE. We, the students of final year, have done a project in a group of 5 under the guidance of Mr. Kiran Kalbare sir and our principal Dr. Nitin Mohide sir. Our project title name was Formulation of Solid Dispersion BSC II Class Drug by Solvent Evaporation Method using xanthan gum as a carrier. Starting with the introduction, solid dispersion was mainly introduced by Sekiguchi and Obi to improve the bioavailability of poorly soluble drugs. Solid dispersion mainly refers to a group of solid products which contain a hydrophilic matrix and a hydrophilic drug. Our main reason for choosing this topic was to mainly increase the solubility of poorly water soluble drugs. Our current approach is to solubilize the water insoluble drug using a natural gum. NaSID is commonly used worldwide. Ibuprofen is mainly used for treating pain, fever. Solid dispersion is prepared by using various methods. First is cleaning method, second is precipitation method, third is co-evaporation dispersion method, fourth is spray drying, and fifth is freeze drying. We took our literature from Sabkal et al. 2020 and second Mr. Gupta et al. This is the structure of ibuprofen, and here are some its important properties. Moving further with xanthan gum, it is odorless and it is tasteless. Our main aim was to synthesize amminated xanthan gum and use it as a carrier in solid dispersion of ibuprofen. Our objective was to synthesize amminated xanthan gum. Our second objective was to perform the pre-formulation studies for drug and excipients. Our third objective was to formulate solid dispersion by various methods. Our fourth objective was to evaluate its system. Our fifth objective was to study it in vitro drug release. Moving further, how we did the amination of xanthan gum. First, we took 3000 ml water plus 60 ml of natural xanthan gum plus we took 25 ml of diethylamine. Then we stirred it for 6 hours. After that we added sodium bromide for 2 hours. Then there was a formation of thick gel. Then we washed that gel with ethyl alcohol. After that we collected the precipitate of aminated derivative from xanthan gum. Some of the characterization of xanthan gum is done by FTIR study, DSC study and XRD study. Some of the pre-formulation studies were done by organoleptic properties such as color, odor, appearance. Second was melting point. Third was calibration curve of BCS class 2 NASD. Fourth was FTI spectroscopy. Then was DSC study. Then was X-ray diffraction, and then was solubility of determination. First was how we did the formulation development. Our first formulation development by preparation of solid dispersion of ibuprofen by using solvent evaporation method. First we mix the drug and carrier in a volatile solvent. Then we mainly removed the solvent from that mixture by various methods such as rotary evaporation method. After that, supercritical anti-solvent and electrostatic fluid bread clothing was done. After that, solid dispersion particles were collected for the oral dosage form. Here are some compositions of physical mixtures and ibuprofen. First is ibuprofen for aminated xanthan gum, which is 1:1 ratio. Second was 1:2 ratio, and third was 1:3 ratio for solid dispersion 1 batch. Second was solid dispersion 2 batch, and third was for solid dispersion 3rd batch. For solid dispersion 4th batch, ratio was composition was taken xanthan gum, and its ratio was 1:1. For 5th solid dispersion batch, we took xanthan gum with ratio 1:2. And for 6th xanthan gum, we took ratio 1:3. Moving further, for the characterization of formulation of solid dispersion method, the methods which we took were DSC, FTIR, XRD, drug content, solubility study, dissolution study, and stability study. Moving further with the results and conclusion, the result which we got was preparation of calibration curve for ibuprofen. Calibration curve was ibuprofen was mainly drawn by using the absorbance of different concentrations. The concentration which we took was 0. For the absorbance which we got was 0, and for concentration 10 we got the absorbance as 0.151. For concentration 20 we got absorbance 0.351. For 30 we got 0.521. For 40 we got 0.713, and 50 we got 0.912. This is the calibration curve of ibuprofen, and this calibration curve was obeyed by Beers-Lambert's law with range 10 to 50 Ug per ml. The correlation coefficient was 0.9986, indicating excellent linearity. These are the formulation studies, and this is the second formulation study, which is saturation stability, and the solvents which we took for was water, which concentration was 20.49. Then we took acetate buffer, which concentration was 10.25. Then we took phosphate buffer, which concentration was 30.16, and when again last we took phosphate buffer, which concentration was 42.48. This is the mainly graphical representation of solubility data of ibuprofen by using a DSC, that is a differential scanning calorimeter. This is the Fourier transform infrared study. These are its various number and its professional functional group. This is the graph of FTR of ibuprofen. And the functional group which we took was CH bindings, C double bond CH stretching, C double bond O stretching, and CH stretching alkaline. And this is the interpretation of ibuprofen which we got. This is the interpretation, and this is the spectrum graph of FTIR spectrum of ibuprofen plus xanthan gum. These are its probable functional groups. Here are again the interpretation of ibuprofen plus amyanated xanthan gum, and this is the graph of FTIR spectrum of ibuprofen plus amyanated xanthan gum. This is the powder X-ray diffraction. This is the powder X-ray diffraction graph, and this is the pattern of XRD, that is X-ray diffraction. This is the in vitro study of solid dispersion, which contains the drug and carrier for various formulations for batch 1, batch 2, batch 3, batch 4, batch 1, batch 6. This is the graph of in vitro drug release study of solid dispersion containing drug and carrier for various formulations. And this is the DSC graph of ibuprofen. The DSC thermogram of pure ibuprofen showed a endothermic peak at 75 degrees Celsius, which shows its melting point, which mainly corresponds to its melting point. And its endothermic peak was mainly detected at 88.5 degrees Celsius and 59.4 degrees Celsius. Evaluation of ibuprofen and was done by UV spectrophotometer, which was measured at 222 nanometer. For solid dispersion batch 1, drug content was 90%. For batch 2 it was 95%. For batch 3 it was 99%. For batch 4 it was 91%. For batch 5 it was 92%, and for batch 6 it was 93%. This is the evaluation of drug content for each batch. Next, moving further with solubility of various physical mixtures of ibuprofen for various batches, distilled water for pH 1.2, for pH 6.8, and for pH 7.4. This is the graph of solubility study graph of ibuprofen. This is the stability study graph. This is stability study table for this stability study table for solid dispersion. Moving at last with summary and conclusion. Our main purpose was to employ amineted xanthan gum, and results of FTR and DSC study were confirmed that there was any chemical interactions or incompatibilities between modified amineted xanthan gum and its excipients. These are some of the references. Some of the references are D.K. Mishra and Antolin M.E. Pharmaceutics, The Science of Dosage Form, 3rd edition. Thank you very much. Thank you.